Now we can start the session. A very good morning to all. It gives me an immense pleasure to extend you a very warm welcome on behalf of the Research and Development Section, King's College of Engineering, who has led all of us for the IEEE expert talk on evaluation of electric vehicles, future challenges and opportunities. I would like to request Ms. S. Aparna, final year ECE, to deliver the welcome address.
Good morning to all. Today, I am Aparna of Final Year ECE to take this opportunity to welcome you all to the expert talk on evolution of electric vehicles and future challenges and opportunities, organized by R&D section and IEEE student branch. I extend my hearty welcome to our most respected Secretary Sir, Honorable Chief Guest Dr. Rajesh M. Pindoriya, our Honorable Principal Dr. J. Arpuda Vijayselvi Ma'am and Dr. P. Shantaraman, DRC Convener and DRC members and other faculty members and my dear friends. We have gathered here to listen and discuss on evolution of electric vehicles, future challenges and opportunities. I ensure you all that you will thoroughly enjoy the webinar and we will definitely take some learns home today. Thank you.
Thank you, Ms. S. Aparna. Now we would like to call Ms. K. Gayatri from third year EC to introduce our resource person.
Good morning, everyone. On behalf of R&D section and IEEE student branch, I extend my hearty welcome to our resource person, and I feel happy to introduce our resource person. Dr. Rajesh M. Pindoriya received the B.Tech degree in Electrical and Electronics Engineering from Rajasthan Technical University, Kota, Rajasthan, India in 2012, and ME in Power Electronics and Electrical Drives from Gujarat Technological University, Ahmedabad, Gujarat, India in 2014. He received a doctorate degree in Power Electronics and Electrical Drives from the Indian Institute of Technology, Mandi, India in 2020. He is currently working as a project engineer at IIT Mandi, India. His present interest and expertise are being inclined towards controlling special electrical motors such as permanent magnet synchronous motor, brushless direct current motor, and switched reluctance motor drives for the application in electric vehicles and hybrid electric vehicles. He is also working on the design of novel power electronics modulation technique for the reduction of acoustic noise and vibration of special electrical motors. Dr. Pindoriya is a founding chairperson of IEEE PELS Site Student Branch Chapter, IIT Mandi. He is a currently mentor of IEEE Student Branch, IIT Mandi. He is a member and executive at large member of PELS Student Subcommittee and PELS YP respectively. Dr. Pindoriya is a member of IEEE, a member of the Institute of Electronics and Telecommunication Engineers, a member of the Institute of Engineering. We are very grateful to Dr. Rajesh M. Pindoriya for accepting our invitation and marking his presence here. Once again, I welcome you, sir.
Thank you, Ms. Gayatri. Now our resource person, Dr. Rajesh M. Pindoriya, kindly asked to take over the session. So please.
Yeah, so first of all, good morning all of you, and thanks a lot for my brief introduction. So now I would request you, if you not started to record the session, then please record the session if possible. So it will helpful to the others also. So sir, already you started to record the session. Yeah, what?
Sir, yes, sir. Recording is started.
Yeah. Okay. Okay. So once again, good morning all of you. So today's session is specially for the electric vehicles. So that is like evolution of electric vehicles, future challenges and opportunities. So thank you so much for the King's College of Engineering to invite me for this IEEE expert lecture on electric vehicles. So starting with the presentation, that is like outlines. So outlines is most important. So audience will show. So what is going on throughout the 1 hour presentation. So starting with introduction to electric vehicles and hybrid electric vehicles. Then schematic layout of electric vehicles and hybrid electric vehicles. After that, major components of electric vehicles. then major challenges of electric vehicle, and finally probable solution of the challenges. So how we can overcome this problem, that is finally we will discuss throughout the presentation. So so starting slide, so maybe the two slide, there is a beginning. So that is like basic fundamental concept of electric drives, because audience maybe the BTech student, maybe the MTech student, maybe the PhD research scholar, and also maybe faculty members. So starting 1 to 2 slide, that is for the BTech student as well as the MTech first year student, because whenever we discuss any topic, first upon we need to know fundamental concept of particular any idea. So nowadays we are talking about electric vehicles, correct? So electric vehicles, heart of electric vehicles, that is like power electronics and electric drives. So now question is, what is a electric drives and why it is required in the electric vehicle? Okay, so you can see slide number 4. So sir, my slide is visible? Hello? Can you confirm that is slide is visible? Yeah, no.
Sir, visible, sir. You can continue, sir.
Yeah, so just let me know whenever it's set to stop. Okay. Yeah. So definition of electric drives. So system employed for the motion control are called drives. So any system we can control the speed of any rotating device, then we can say it is a drives. But here terminology, it is a electric drives. So electric drives means drives employ electric motor are known as electrical drives. So whatever drives we employ for electrical machine, then we can say it is our electric drives. So this is a basic fundamental concept of electric drives. Now question is, why it is required? What is the necessary of this electric drive? To control the speed and torque of electric motors. That's why we required electric drives. So why speed and only torque? Because whenever we can say electric vehicle, then we have to control only two parameters. One is a speed and second one is a torque. So speed and torque both are mechanical quantity. As an electrical engineer, we have two quantity. There is like voltage and current. So voltage is directly proportional to the speed and torque is directly proportional to the current. Suppose you want to control the speed, as an electrical engineer, we can able to control the voltage of supply. Okay, and suppose you want to control of the torque, then as an electrical engineer, we have to control the input supply current. Then ultimately we can say we can able to control the speed and torque of any electrical motors. Okay. So till now we understood, so what is a electric drives, why it is required, what are the major components we need to control in the electric drives. Every time we need to control the speed and torque in the electric drive. So that is a major components. Okay. Now what is the applications? So we can see electric vehicles, ceiling fan, refrigerator, lift, vacuum cleaner, and ship. So nowadays everywhere use the small level motor to the high level motors. Okay, so small level you can say the like computers are CPU fan as well as the like mixture, home, domestic application as well as the industry application, big application. So we have available milliwatt rating to the megawatt rating of electric drives. So we have various applications. Nowadays everywhere available the like electric drives. Okay, so these are the major applications. Now slide number 5, that is a most important slide, because we need to understand the electrical drives components before going to the electric vehicle. As I said, electric drives, it is a heart of electric vehicle. Without electric drive, we cannot design the any electric vehicle. So it is a heart of electric drives. Okay. So most of the students already know about this major components of electric drives, but I want to spend around like 2 minutes on this slide number 5. So we can say electrical source from the left hand side of the slide number 5. So that is like electrical source. We have universal two source, that is a alternating current and DC current. So that is a direct current. So we have these two universal source. So once we have this electrical source, then we can give supply to our power processing unit. So what is a power processing unit? So power processing unit is nothing but conversion of the power from one source to another source. So we have two sources, that is AC and DC. So depend on application, we need to convert power from AC to DC, otherwise DC to DC, otherwise DC to AC. So there is a power processing unit. So power processing unit is again a heart of electrical drives. Okay. So electric drives, it is a heart of the electric vehicle. And what is a heart of electrical drives? So that is a power processing unit. So power processing unit is a heart of electric drives. Okay. So there is a controllable power, it is a give to the electric motor. So any kind of electric motor. So we have AC motor and DC motor. So AC motor, we can say induction motor, PMSM, BLDC, SRM motor. So any type of motor you can connect with our power processing unit. And that is ultimately this is a drives. So we can say this is like closed loop system. So you can see that's a sensor part. So suppose you want to control the speed and torque. So we need to measure the voltage, current, flux. So this is a torque. So we need to connect the sensor part. So this is a different type of sensor. We need to connect with a feedback closed loop system. And sensor is basically sense the signal. That is like voltage and current sensor signal the electrical quantity, also mechanical quantity, and finally convert into electrical quantity. And that signal is due to our controller part. So controller is maybe the DSP controller. DSP stand on digital signal processor, and FPGA, that is a stand on field programmable gate array. So depend on your drives switching frequency, you can design your controller. Okay, maybe the FPGA controller, maybe the DSP controller, maybe the microprocessor. But nowadays people use the FPGA because FPGA has high clocking frequency, and that is a most required. And again, it's a reference signal. So reference signal may be the speed, otherwise maybe the torque. And finally, this controllable signal is due to the power processing unit. So these are the like overall drives, and ultimately we need to connect the load with our electric motor. So load may be the any type of loads. So that is an electric vehicle, fluid flow, compressor, refrigerator, etc. Any type of load we can connect depend on our electric motor. So these are the 5 major components. We can say power processing unit, electric motor, sensor, controller. So these 4 are the major components in the electric drives. So this is the major components of electric drives, not the electric vehicle. Okay. Now, what is an electric vehicle? That is the most important. We have already IC engine. So why it is introduced the electric vehicle? What is the necessary for it? So electric vehicle use one or more electric motors or traction motors for the population. Okay. So in the IC engine, we used like maybe the like diesel, maybe the like petrol, maybe the like gas. But whenever we can say electric vehicle, then we cannot use petrol, diesel, or any type of gas. We can run our electric vehicle by electric supply. That is like we can say it is a free pollution. So that is a not generate any CO2 gas. So we can say this is a pollution less electric vehicle. Otherwise we can say pollution less vehicle. Okay. Then another terminology, that is like hybrid electric vehicle. Then what is the meaning of hybrid electric vehicle? So meaning of hybrid electric vehicle, that is a combination of electric plus IC engine. So sometime maybe for long driving we need the both vehicle, correct? So that is maybe IC engine plus electric vehicle. So industry designed the hybrid electric vehicle. So that is a engine is both engine. That is a diesel engine plus electrical engine. So we can say that is a hybrid electric vehicle. So nowadays industry designed the both vehicle, electric vehicle as well as the hybrid electric vehicle. Now, what is the benefit? We have already IC engine. We have lot of IC engine running on the road. So what is the benefit? Why we launch the like electric vehicle? So you can say this slide number 7 is most important. There is a like we can say before going to launch any new application, first we need to understand what is the benefit. Suppose we launch this new application. So what is the benefit and what is the disadvantage? Okay. So first we can say benefits of driving of electric vehicles. Okay, so save money. So save money means initially we have to spend too much amount, maybe the 20,000, maybe the 40,000 high compared to the IC engine. But ultimately in the future, you will save maybe the 70% fuel cost. Okay. So save you more than 70% on the fuel cost. So once you spend around like maybe the 1 lakh rupees on the two-wheeler vehicle, then in the future, maybe the within 5 years, you will get 70% reimbursed from the fuel cost. Okay, so you can able to save 70% on the fuel cost. So that is the most important. Nowadays, petrol price is, you can say 100 rupees, otherwise maybe the 105 rupees, and diesel price maybe the 85 rupees or 90 rupees, depend on the city to city. Okay, so first one is a save money. Second one is a clean, is a green. So emission less operation, no emission, no CO2, no pollution. So that is a nowadays is a major focus on the clean energy. We can say the like CO2 less application because of the greenhouse effect. So that is a major advantage. Second thing is reduce the dependency on the foreign oil. So nowadays we know suddenly increase the cost of the petrol and diesel. So we have to depend on the other country. So we have to depend on the international policy and everything, because we don't have a oil in the India. So we can say reduce the dependence on the foreign oil and have a higher satisfaction level to drive the electric vehicle because of the smooth operation, because of the electric motor on the electric vehicle. So that is a smooth operation because there is a no IC engine. So we can say it is a higher satisfaction level. So these are the major benefits of driving electric vehicles. Now we can say the comparison. So why we need to, suppose somebody want to buy the electric vehicle, so we need to first compare with IC engine, correct? So we can say like petrol, so that is a range maybe the 440 miles. So that is like suppose there is a range is a 440 miles, then hybrid electric vehicle same range, then refuel time. So comparison now with refueling. So refueling time is a 5 minutes. Whenever we can say hybrid, so again is a 5 minutes. But whenever we can say the plug-in hybrid electric vehicle, so that is like less than 1 hour. But whenever we can say 100% electric vehicle, that is a battery operated, so it will take around 4 to 8 hours. But nowadays people working on this charging topology, how we can reduce the charging time. So we can say energy efficiency. So IC engine is not efficient because there is a lot of losses and also increase the CO2 level and everything. So energy efficiency, we can say not efficient. But other electric vehicle, that hybrid, plug-in and 100% battery operated, that is like most efficient vehicle. Okay. So ultimately 100% IC engine is replaced with a electric vehicle, but it will take some time. Now, configuration of electric vehicle, correct? So whenever we can say electric vehicle, then we need to understand what are the major components and what are the schematic layout, otherwise we can say the major configuration of electric vehicle. So I divided into 3 parts. So first one is top one level, that is like electric population subsystem. Second one is there is a blue color, that is like energy source subsystem. And third one, that is a green, light green, that is a like auxiliary subsystem. So starting from the top one, that is like electric population subsystem. So we can see the input, that is a like brake and accelerator. So this brake and accelerator, that is a control by the driver. Okay. So this is the most important, that is a brake and accelerator. And there is a major components in the electric population subsystem, that is like electronics controller, power converter, electric motor, mechanical transmission shaft, and finally wheel. So these are the major components of the electric population subsystem. So in this domain, maybe the electric engineering working on this area for the electric population subsystem design. Okay, because all the parts from the electrical engineering. So that is like electronics engineer, maybe we can say the power electronics engineer, we can say electrical engineer, any type of engineer working on this area. Then energy source subsystem, there is an energy management unit, energy source, and energy refueling unit. So we have 3 major components in the energy resource subsystem. and auxiliary subsystem mostly working on the mechanical domain, because we need to control the temperature, auxiliary power supply, power steering unit, everywhere, also body of the electric vehicle. So mostly this part working for the like a mechanical engineer. So these are the major configuration of the electric vehicle, otherwise we can say major components of electric vehicle. So now you can see the schematic layout of electric vehicles and hybrid electric vehicles on slide number 10. So that is a starting from left hand side. So that is a front wheel, then transmission shaft, and motor and generator. We can say the both motor and generator, because regenerative braking is there in the electric vehicle. So that's why I written motor and generator. Any type of motor, nowadays people use induction motor, BLDC motor, PMSM and SRM motor. Then power electronic circuit, that is the heart of electric drives. Energy storage system, we need to maintain the energy. So we have to maintain the constant DC supply voltage. So that is, we can say, overall energy storage system. And finally, software part, we can say the controller part, that is like FPGA, DSP, microcontroller, depend on clock frequency and depend on the vehicle category. That is a two-wheeler, that is cycle, maybe that is like three-wheeler, four-wheeler, depend on the vehicle application. We need to choose the controller, that is the hardware part. Okay, so this part is, maybe we can say, the electric vehicle. Now IC hybrid electric vehicle, we have to add only IC engine plus fuel tank. With combination of IC engine and hybrid electric vehicle, we can say this is a hybrid electrical vehicles. Okay. Now you can see slide number 11, that is a pictorial view of the electric vehicle. So this is an actual electric vehicle. So major components is electric motor and generator, combination of motor and generator set, AC to DC converter, again DC to DC converter, inverter, battery junction and battery. So these are the mostly we can say 6 major components in the electric vehicles. Now finally we can say the challenges. What type of challenges nowadays people facing for the electric vehicle? So I divided this challenge into major 4 parts. So that is slide number 12. So first major challenge, that is a technical. Second one is a infrastructure. Third one is a policy, and fourth one is a market. Okay. So let's see, we can understand one by one. That is the first one we can cover, like technical part. So that is the efficiency of battery. How we can increase the efficiency? Suppose you want to drive for 100 kilometer in the one day, then is it possible to your two-wheeler is drive 100 kilometer only one single charging of the battery? So that is the efficiency of battery. How we can increase the efficiency of battery? So we can easily drive 100 kilometers our electric vehicle. Then driving range of electric vehicle. Okay, charging time. So how we can fast charge our electric vehicle? Suppose you have IC engine, then just go to the petrol pump and charge your vehicle within a 1 to 2 minutes. But suppose you have electric vehicle, then maybe you have to stop maybe the 1 hour, maybe the 2 hours, maybe the 5 hours. Depend on which type of battery you have, depend on which type of battery management system, which type of battery you use. Every parameter is considered. So that is a charging time. Safety. Nowadays you maybe heard in the daily newspaper around 4 electric vehicle blast, around 5 electric vehicle blast in Chennai, in Tamil Nadu, maybe in the Gujarat, maybe in the Delhi. Why? Because of the not good management, not good battery management system. Because this is already electric vehicle, so you know that electric is a very dangerous. So suppose it's short circuit, then ultimately it is a blast. So we have to work on the safety. Then environmental impact. So these are the 5 technical challenges we have to work out on this topology. Okay. Second one is infrastructure. So charging infrastructure. Suppose we have maybe we can say we have like around 1 lakh electric vehicle across the India. Okay. So we need to make the sufficient charging station to charge our electric vehicle. So there is a major problem. There is like charging infrastructure. How we can design the charging infrastructure? Okay. Then smart grid. So smart grid is nothing but two-way communication with the customer and the power plant. Then we can say it is a smart grid. So we can communicate with the customer and the power station. Then we can design the smart grid. So that is one of the major challenges nowadays. People working on the smart grid. So we can create the good smart grid infrastructure and maintain the electric vehicle safely. Okay, battery recycle. So how much time it will take to recycle the battery? Okay, and dedicated lanes for the electric vehicles. So is it possible to we can design the dedicated lane for the electric vehicles? So that is another infrastructure issue. Then policy. So policy is basically for the government side. So ultimately government, we can say it is like as a an Indian employee, it is our policy. So government policy. So we have to design the policy. So taxation, tax of the electric vehicles as well as the components. So how much tax we can reduce to design the electric vehicle? Subsidy on the fossil fuel, electricity tariff policy. So we have to work out on the policy maker. So customer is easy to buy the electric vehicle. So ultimately we replace IC engine with electric vehicle. So as an Indian government, that is like 2050, we can replace all IC engine with electric vehicle. So we have to work out on the policy. Then finally, there is a market scenario. So how we can say you can buy the electric vehicle? Suppose educated people is understand easily. So we have to buy the electric vehicle. Suppose as a common man, otherwise we can say the helper. So we have to give the proper guidance. So you have to buy the electric vehicle. So that is a one-time investment. Also, also government give the subsidy to buy the electric vehicle. So testing and certification, vehicle servicing, high capital cost and financing, and then we can say the electricity quality, market for the electricity storage, consumer precaution, and raw material for the battery. So we have to tell the customer. So this type of support you will get once you will buy the electric vehicle. So as educated people, we have to tell the common man. So once you buy the electric vehicle, then ultimately it will helpful to reduce the cost of your electric vehicle. So that is the most important thing. Okay. So these are the most challenges. That is the technical challenges, infrastructure, policy, and marketing. Okay. Now types of electric vehicles. So that is like battery operated electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, and fuel cell electric vehicles. So due to time limitation, I am not going to explain every types of electric vehicle in the today's presentation. If you have any question, then after this presentation we can discuss in the question answer session. So I will just brief about types of electric vehicle and how it is work. Suppose you are a PhD scholar, otherwise MTech final year student, and you want to discuss more, then personally give me personally send me the email. Then we will discuss over to phone. Okay. Now battery electric vehicle. So what are the major components? So you can see the left hand side of the slide number 14. So that is a battery. So we need to maintain the constant DC link voltage. So that is a battery part, and there is an inverter. So inverter is nothing but there is a power processing unit. So we need to convert from DC power to AC power, depend on the which type of electric machines is there. And this machine is directly connected with the transmission shaft of the wheel. So through machine, we need to transfer the power to the wheel of the electric vehicles. Okay, so there is a driving wheel power, we can say, speed, single speed gear, we can say. Okay, so these are the battery operated electric vehicle. Now slide number 15, that is like comparison of different type of electric vehicle. So you can see I made one table for the better understanding. So suppose we can say the battery operated electric vehicle. So driving component is electric motor. So you can see the problem. What is the problem? That is a battery price and capacity. Second problem is a range. Third problem is the charging time, availability of the charging station, and high price. So these are the 5 problems in the battery operated electric vehicle. Now let's suppose hybrid electric vehicle, then major driving components are electric motors and IC engine. Then features of this hybrid electric vehicle, there is a very little emission. Why emission? Because IC engine is there, that's why emission. Large range, we can produce a large range because of the IC engine. Can get the power from both electric as well as fuel. Available commercially because IC engine, there is a petrol pump and diesel pump available in the market. Okay, so available is commercially. But what are the problems? Management of the energy source. We have to manage the both source. That's like IC engine plus electrical engine. So there is a management of energy source. We have to make the specific energy management system. Battery and engine size optimization. So we have to ultimately reduce the size of the engine. Okay, so these are the major problems. Now fuel cell electric vehicle. So there is an electric motor, fuel cell. Fuel cell, that is like H2O. Nowadays people working on the H2O. There is a like hybrid hydrogen oxygen fuel tank. Okay. Otherwise we can say the hydrogen operated electric vehicle also. Okay. So mostly people use nowadays that is like hydrogen operated fuel cell. So there is a features, very little emission, high efficiency, not dependent on electric supply, high price, available in the commercially. But what are the problems? Cost of fuel cell, feasible way to produce the fuel, because we cannot produce hydrogen easily. We have to make the proper process and then ultimately we produce the hydrogen. Okay. Availability of the fueling facility. So these are the major problem. Suppose you are a research scholar, then we have to work out on this particular problem to resolve the issue in the electric vehicle. Now main issue, as I said, nowadays electric vehicle is blasting and there is a fire and everything. So what are the major components? There is a battery. Suppose there is a no battery, then fire is not happen. Due to the battery, there is a fire is problem. Okay. So common battery used in electric vehicle, there is a lead acid, nickel metal hybrid battery, lithium ion battery, nickel zinc battery, and nickel cadmium battery. So this type of batteries nowadays people use. Also nowadays people working on the ultra capacitor technology. Now, as an electrical engineer, we can say we have to work on the like electric motors, correct? So we have induction motor, PMSM and BLDC motor. We can say the permanent magnet motor and SRM motor. Nowadays people are working on the switch reluctance motor for the application in electric vehicle. So what are the difference between these three motors? So induction motor, most of the people know, because induction motor is a fundamental concept. We can say after the DC motor, we can say induction motor is a AC fundamental concept. So stator side is a three-phase winding and rotor side is a aluminum sheet or bar. So there is a no winding on the rotor side. And there is a like rugged construction. So easy to control the induction motor. But permanent magnet motor, we can say stator is the same like induction motor. So there is like three-phase winding. But on the rotor side, there is a no aluminum sheet or bar, no winding. Permanent magnets are there on the rotor side. So there are more major benefits of the PMSM and BLDC motor. And the stator, that's like three-phase winding in the case of SRM. So stator of all the motor that are the same, but we need to work out. Otherwise, we can modify the rotor structure and make the efficient design of the motor. So in the case of SRM, so SRM stand on switch reluctance motor. So on the stator side, there is a three-phase winding, but the rotor side, there is a pieces of steel, so laminated steel. No permanent magnet, no winding, no aluminum sheet, only pieces of the laminated sheet. So we can increase the efficiency and we can reduce the loss. So nowadays people use the induction motor, BLDC motor, PMSM motor and SRM motor in the case of the electric vehicle. So these are the various typical torque speed characteristic of the induction motor, permanent magnet motor and SRM motor. So I am not going in detail analysis. Suppose you are a designer of the electric vehicle, then first upon you have to work out on the speed torque characteristic of particular motor, maybe induction motor, maybe the PMSM, maybe the SRM motor. So based on this characteristics, you need to choose the electric motor for the electric vehicles. Okay. Now these are the comparison of the electric motor. So I put the like make the one table for the comparison of BLDC motor, PMSM motor, induction motor, and SRM motor. So in the brief, I can say vehicle, in which motor vehicle use. So you can see BLDC motor, Toyota used in 2005. Okay. PMSM motor, Toyota, Nissan, Seoul electric vehicle. So many company use. Here I put only few names. So many company use PMSM and BLDC motors. Induction motors, you can see the Tesla Model S, Tesla Model X, Toyota, GM EV. So many industry people use the induction motor because of the rugged construction. Okay, SRM motors. So nowadays people are working on the SRM motor. So till now, for my knowledge, only one industry company used the SRM motor. Nowadays, Tesla also work out on the SRM motor for the racing car. Okay. So these are the typical advantage, disadvantage, in which company used which electric motor for electric vehicles. Now, like operation coordinator, you already heard about 4-quadrature operation, correct, in the electric drives. But in the case of electric vehicles and hybrid electric vehicles, in the which quadrature, otherwise we can see the which region, which type of engine will operate. So we can say the starting, for the starting we need to give the most torque, correct. For we can use the IC engine plus battery. Okay, so in the starting case we need to give the more power. Suppose there is a once the motor start, otherwise we can say once the electric vehicle start, then it is a smooth area, we can say the plain area, then low speed running and also require the low torque. Okay, so we can say the battery is working is sufficient. Then accelerate, we need to up from the lower area to up area. So we need to accelerate our electric vehicle. So again we need to give the more power. So that is a IC engine and the battery working together. Okay. Then again it's a plain area, so that is a high speed running. So again it's a IC engine. And suppose from the high to low, there is like slope. You need to run your electric vehicle on the slope. So that is a braking operation. So nowadays, one of the major research area, there is a regenerative braking in the electric vehicle. So there is a battery charging. So ultimately we can charge our battery by self in the electric vehicle. So that is like battery regenerative braking charging topology. So slide number 21, there is like typical placement of different power electronics converter in the electric vehicle. So you can see the utility plug. So we can say this is like main power supply. So 3-phase power supply, otherwise 2-phase single-phase power supply. So main utility plug, then AC to DC converter. So that is nothing but it is a power processing unit. And this is a bus bar. We can say the DC bus bar. So we need to maintain the constant power. And for the acceleration operation, there is a motor drive and the motors. And we can say the discharging component. So that is like DC to DC converter and energy storage system. So for the various cycle of operation, we need to charge, discharge, braking operation, recharging, rectifying, inverting. So you can see every I put the like arrow, that is like rectifying, inverting. Suppose you need to again send power back to the like grid. So we can say the inverting the power, rectifying the power, acceleration, discharging, so everything. So these are the flow of, so we can say this is a typical placement of different power electronics converter in a electric vehicles. Now, effects of electric vehicles. So you know, in the world, every system is not 100% efficient. Okay. So suppose some advantage is there, then also there is some disadvantage. Okay. So suppose we can say there is a electric vehicle, we can say there is a lot of advantage compared to the electric, compared to IC engine. But of course, there are some disadvantage of the electric vehicle. There is an impact, we can say there is an impact of electric vehicle. So maybe there is a positive impact, maybe the negative impact. Okay. So any system is not 100% correct. So there is a maybe positive, maybe the negative. So impact on the power grid. So ultimately there is a electric current, correct? So nowadays people working on the IC engine. So there is a not correlate with the power grid, correct? But nowadays people working on the electric vehicle. So there is a direct relation with the power grid. So first we can say negative impact and positive impact. So let's see, first we consider the positive impact. So what is a positive impact on the power grid through electric vehicle? So that is a positive impact. First one is a facilitating smart grid. So we can design the smart grid, and that is a good for the power grid. Vehicle to grid operation. So we can easily connect our vehicle to grid, and using the smart grid we can communicate with the power grid. And integration of the renewable energy system. So renewable energy system means solar, wind, hydro. So we can generate the more renewable energy from the renewable energy resources, and integration through electric vehicles. So these are the three positive impact. But what are the negative impact? So we can say first negative impact, that is a voltage instability. Suppose you go to the charging station of the electric vehicle and you just put your charging plug in the charging station, then suddenly there is a voltage instability happen. Okay, because current rating is maybe the 16 ampere, maybe the 20 ampere, depend on the drives, depend on the electric vehicle. So you take the lot of power from the power grid. So suddenly voltage instability happen, increase the peak demand. So suddenly you consume the lot of power, so increase the peak demand, so ultimately unbalance the voltage. Okay, so that is a most important problem, how we can resolve the unbalancing of voltage. Harmonics, voltage sag and power losses. Suppose somebody is working on the power system, so these are the major components in the electric vehicle. So we have to work out on this problem, so we can get our power grid is a balanced operation. So these are the impact on the power grid. Now impact on the environment. So what are the positive impact and negative impact? So in the environment, so there is a positive impact. So we can say the less greenhouse gas effect. So nowadays there is a major challenges in the environment. There is a greenhouse effect. So by using of the electric vehicle, so we can say we produce like less greenhouse gas emission. Impact on economics, lower operating cost, and chance to benefit from vehicle to grid connection. So these are the three major impact on the electric vehicle. So the impact on power grid, impact on environment, impacts on economics. Now limitation. What are the limitation? So there is a social problem, social acceptance. As I said, as a common man, otherwise like helper who don't have like sufficient knowledge on the electric vehicle, so why they will buy the electric vehicle? Suppose they will get the like bike, Honda bike, maybe the cost of maybe the 80,000 and 90,000, that IC engine bike. But this electric vehicle bike, maybe the cost is 1,20,000, maybe the 1 lakh rupees, maybe the 1,10,000 rupees. So why common men pay around like 10,000 more to buy the electric vehicle? So one is the social acceptance. Insufficient charging station. Second one is the insufficient charging station. Suppose somebody want to buy the electric vehicle, but due to the insufficient charging station, then how they will recycle? Otherwise, we can say how they will refueling the battery. So that is another problem. Then technology problem, limited range, long charging period, and safety problems. So these are three major problems in the technology side. An economics problem, that is a high price. So there is a economics problem. Okay. So whenever we can say limitation of electric vehicle, then we have three problems: social problem, technological problems, and economics problems. So based on the research, so we can say the tentative solution of the current limitation of electric vehicle. So limitation, first limitation is limited range. Second one is a long charging period. Third is a safety problem. Fourth one is a insufficient charging station, and fifth one is high price. So these are the major challenges in the electric vehicle. So what are the current tentative solution? So suppose it's a limited range, so we can work on the better energy source and energy management technology. Now there are a lot of researchers working on the energy management system as well as battery, better energy sources system. Okay. Second one is a long charging period. So we need to work on the better charging technology. Okay. Safety problem. So how we can resolve the safety problem. So we can say advanced manufacturing scheme and build the quality. So using this advanced manufacturing scheme, we can resolve the safety problem. Insufficient charging station. So placement of sufficient station capable of providing the service to all kinds of vehicle. Nowadays, you know what happens. Suppose you will buy the Ola vehicle, you will buy any Ether vehicle, any reputed electric vehicle. So they have like self-charging station. So, but in the case of IC engine, we have like anywhere we can refuel our vehicle. But in the case of the like electric vehicle, we need to give particular specific charger for this particular vehicle. So we need to work on the like common charging facility. You have any XYZ company electric vehicle, okay, high price. So mass production, so we need to give the mass production, advanced technology, government initiative, okay. So by using this initiative, we can reduce the price of electric vehicle, okay. So these are the tentative solution of the current limitation of electric vehicle. Now, what are the footrace in the electric vehicle? So footrace are charging, that is a recharging, hybrid electric vehicle, hydrogen fuel cell, and auxiliary power unit. Okay, so these are the major factors that is nowadays footrace in the market. So like recharging, so footrace, we can say the weight of charger. So ultimately we need to reduce the weight of charger. Then ultimately we can say the reduce the weight of overall electric vehicle. Durability, cost, recycling, size, and charging time. So these are the under the recharging footrace factor. What about the hybrid electric vehicle? We can set the battery, durability, weight, and cost. These are the under the hybrid electric vehicle. Hydrogen fuel cell, cost, hydrogen production, infrastructure, storage, how we can able to store the hydrogen, durability, and reliability. So these are the major factors for the hydrogen fuel cell. Auxiliary power unit. So auxiliary power unit is basically for the like mechanical design. So how we can design the structure of our electric vehicle. So there is a size, cost, weight, durability, safety, reliability, cooling, and efficiency. So these are most of the part that is like by mechanical engineer. Otherwise, we can say the like a material engineer. So based on the material, we can say our electric vehicle is a rugged construction. Also, it will work a very long time. So you need no need to replace any engine immediately. So these are the major factors that is a cover under the auxiliary power unit. Now, slide number 26, there is a major trends and future developments. So you can see from the down of the pyramid. So starting from down, so overhead power supply, wireless power transfer. So nowadays also one of the major research going on the wireless power transfer, better battery topology, better charging technology, and vehicle to grid and grid to vehicle topology. So these are the major trends and future development program whenever we can say the electric vehicle production. Now current area of the research. So there is a like reduce mass, how we can able to reduce the overall mass of the electric vehicle. So ultimately increase the efficiency of the motor. Decrease the material and manufacturing cost. So how we can able to decrease the material cost. So ultimately reduce the cost of electric vehicle. Improving the hardware. So we can improve the hardware. So ultimately it is a rugged construction. So it will work long time. Battery. Alternatives to maximize the nickel metal hybrid that is a currently used. Okay. So we need to work on the battery capacity. So which type of battery is good for the electric vehicle? So these are the four current area of the research. So maybe this will helpful for the research scholar as well as faculty member to work on the electric vehicle for this particular research area. So there is a traction motor. So we can say, suppose any PhD scholar working on the like traction motor. So there is like a problem, particular identify problem. There is like electromagnetics, thermal, mechanical, NVH, that is like noise, vibration, harass, and testing. So these are the major 5 problems which are produced in the design of the electric motors. Okay. Electric vehicle chargers. So there is a power processing unit, hardware design, embedded coding, testing, that is a hardware and software in the loop, machine in the loop, and hardware in the loop. So using these 5 terminology, you can produce the better charging topology. Okay. Traction battery, electrochemistry, PEG simulation, cell simulation, PEG thermal. So these are the type of the analysis once you design the battery. Suppose you are a battery design engineer, so you have to work out on the electrochemistry, PEG simulation, cell simulation, and PEG thermal analysis. Once you analyze these 4 type of analysis part, then you can say our traction battery is very good. Okay. So finally, I can say, finally conclusion. So discuss about the electric drives and its application, major components of electric vehicles and hybrid electric vehicles, various type of electric drives and power electronics converter topology, and we also discuss major challenges of electric vehicles and current area of the research in electric vehicles, and finally we uh, uh, discuss about the solution for challenges. Okay. So these are the few references which I used to prepare this presentation, and thank you for your attention. And if you have any query, so please ask me. So I would happy to give your answer. So I can say the future is really in our hands. Suppose you want to make your bright future, so you need to work out on the like green energy, and also we need to produce like less greenhouse emission. So finally, I can say that thank you so much for your attention. Now session is open for the question answer. If you have any question related to electric vehicles, so feel free to ask your question. I will happy to give your answer. Thank you so much.
Thank you very much, Dr. Rajesh M. Pindoriya. I hope you all enjoyed this amazing presentation. Now, Dr. Rajesh M. Pindoriya will answer the questions from the participants. Participants are requested to raise their queries regarding the topic. Any questions from the participants?
Sir,
Yeah.
Sir, can you hear me?
Yes. Go ahead.
Sir, can we recharge an EV with a solar panel? If so, what is the capacity?
Sorry. Can you just repeat?
Can we recharge an EV with a solar panel? If so, what is the capacity?
Yeah. So very good question. So that capacity of the solar panel, that is a depend on the which type of electric vehicle. So there is like cycle, two-wheeler cycle, there is like bike, yeah, three-wheeler. So nowadays people use also on the roof of the three-wheeler put like solar panel. Also in the village area, also like small city, people make the electric vehicle to the solar panel. So on the like bicycle, they put on the roof side solar panel. So it will also good to protect on the sun, and also it will charge our electric battery. But that is ultimately depend on the which type of motor you use and what is the capacity of the that electric motor. So what is the rating of the yeah. Yeah, so one question, how to predict the state of temperature is like SOC. Okay. So state of temperature, we need to put like sensor in the battery, on the battery. So ultimately increase the temperature by continue using of the battery. So we need to put like temperature sensor and continue we need to monitor this temperature. So that is terminology we can say this is condition monitoring of electric battery. So based on this control algorithm, we can monitor the temperature of electric vehicle, and then we can give the sufficient cooling system to maintain the constant temperature, maybe the like 20-degree constant temperature, maybe the 15-degree temperature. That is again depend on the battery capacity. So which type of battery we can use, and which type of which type of chemical we can use in the battery. So depend on this battery chemical, we can maintain the temperature using condition monitoring system. How to optimization technique will overcome the problem in electric vehicle. So which type of problem actually here talking? So how optimization technique will overcome the problem? So can you just explain more about this question? How optimization technique will overcome the problem in electric vehicle? So which type of problem particular? So this is the most important. Okay. So
Sir, we have one more question from the participant, sir.
Is to better to recharge and electric vehicles at home or at a public charging station?
Sorry. Can you repeat?
Is to better to recharge an electric vehicles at home or at a public charging station?
Yeah, so charging station means we need to give the sufficient charging station. So there is another technology that is like, we can say, the sweeping the battery. So suppose you don't want to go with the like charging station. So we have another technology that is like sweeping the battery. So we need to just sweep the battery. So we need to just discharging battery just remove from the electric vehicle, and we need to just insert the charging battery. So within a 1 minute we can charge our battery. So that is like electric sweeping battery technology. Okay. So how to eliminate the battery current ripple in the electric vehicle? Yeah. So this is a very good question. How to eliminate the battery current ripple in the electric vehicle? Yeah. So that is basically we need to maintain the constant DC link voltage. Suppose your battery is not produce the constant DC link voltage, so ultimately there is a ripple in voltage, and also we can say ripple in the current, because current and voltage both are dependent to each other. Suppose there is a voltage is not constant and ultimately produce the current. So one of the major way you can reduce the current ripple in the battery by proper controlling. So we need to manage the like battery management system. So that is a BEMS, battery management system, we can say. Okay. So there is a battery management system, BMS technology. So we need to work out on the battery management system. So lot of control algorithm available to produce the like constant voltage, DC link voltage. Okay. Using the battery management system. Okay. Second question, what is the maximum energy density of the ultra capacitor? So I don't have sufficient knowledge on the ultra capacitor technology. So I cannot give the proper answer on the maximum energy density of ultra capacitor, but 100% I will check out and let you know. So what is the maximum energy density of ultra capacitor? Okay. So any other question now? So audience asked a lot of questions. So I hope audience really enjoyed this session. So if you have any more questions, just let me know. Otherwise, just after some time, maybe if you have any questions, so please email me. So we can discuss more about your question and try to find out the solution. Okay. So thank you so much. If you have any question, then ask me. Otherwise, we can, I think, conclude the session.
So yeah, hope so. The queries are sorted. Thank you, sir, for the great presentation. It was a pleasure to have you with us. Thank you all for attending. We hope you have learned and enjoyed this presentation. Now I'd like to call Ms. V. Maheshwari, third year EC, for vote of thanks.
On behalf of King College of Engineering, I take this opportunity to propose the vote of thanks those who have directly and indirectly contributed this webinar on evaluation of electric vehicle future challenges and opportunities. At the outset, I thank our chief guest and resource person, Dr. Rajesh M. Pindoriya, We are really enlightened with the knowledge. We are thankful our Honorable Secretary Sir, beloved Principal Man for this motivation. I would like to thank our DRC convener, Dr. P. Santaraman for his enthusiastic support. A special thank to all DRC members, teaching and non-teaching staff for this constant support and coordination. Our heartfelt thanks to our students for active participation. With this warm words to kind message, we are moved to